Alright, so before we get into muscle or resistance adaptation, we have to talk AMPK and AMP because it's going to kind of be our transition point, but also how we're going to see why one thing works and the other doesn't, or why these two are split apart. AMP, if we go all the way back to our first chapter, we have ATP, ADP. We've been talking about those two and how ATP and ADP work together, but we have 3 phosphates on ATP, and when we shoot a phosphate off, we go to ADP. Well, there's still 2 phosphates on ADP, so we can shoot another phosphate off of ADP and make AMP. AMP is our lowest form of energy. We have used all of our energy. We are going at it and we have no energy left. AMP is going to show up, and then our enzyme is AMP kinase. So AMPK is going to be a huge, like, red flashing light to our system, and it's going to be like, all right, now it's time to adapt because AMP has been showing up, and it is our main energy sensor, and it is going to increase our substrate of utilization. So we're going to start firing all these things. PFK2, which is going to increase glycolysis. CD36, which is going to increase our ability to use fat energy. Increase in PGC1 alpha. PGC1 alpha is super important because guess what? It does what we talked about 2 videos ago. It's going to increase mitochondrial biogenesis. That is huge. And what does that mean? Increase in VEGF, because we're going to start sprouting new capillaries. PGC1 alpha is going to increase our calcium, our increase in the electron transport train activity, our increase in insulin and increase insulin. And it's going to increase our NADH and NAD. Increase in NAD and a decrease in NAD, which means that CRT1 is going to get activated, which is our longevity hormone. All of this is going to work together, and it's going to work with resistance training and endurance training. Well, it's going to work with endurance training along with our calcium, P38, and MAPK. All of this works together, but the main thing we got to know about AMPK is once AMPK is activated, we can no longer adapt resistance training, because resistance training has a block on it. When AMPK shows up, we can no longer adapt our muscle to resistance training stimuli because of TSC12 or 1/2 is going to inhibit mTOR. And we'll talk about mTOR in a minute, but AMPK is going to inhibit resistance training. It is an endurance training stimulus only. We can only adapt endurance training with AMPK, or we cannot adapt resistance training with AMPK. It is purely endurance training adaptation.